Hello and assalamu alaikum everyone. Welcome to another tutorial of simulation and modeling. I am with you Shajadur Ahmed. So today we are going to discuss about the second part of lecture 4. Previously we have discussed about the single channel queue where we have found only on queue and on server, and today we are going to see a broader picture of single channel queue, which is double channel queue. That means in this time we will see a scenario where we can find that there are two different servers. So let's move on. So this problem is actually called as Abel-Baker-Karhoff's problem. So it has been described about a drive-in restaurant where Karhoff takes water and bring food to the car. So drive-in restaurant, a kind of a restaurant where customer came with their car, and rather than getting out from the car, they actually give order from inside the car, and the Karhoffs or the bearers actually take water from the customer and bring food to their car. So this is how a drive-in restaurant actually works. So there are some assumptions, set of assumption, as we know that simulation will start with a set of assumption and as with a scenario. So car arrive in a manner shown in table 2.11, the interval time. So the interval time is now given. Remember the previous case. In that case the interval time is not directly given, rather than it has been said that the interval time has same probability of occurrence. So we have divided the number of interval by we have divided 1 by number of interval time and then find out what are the probability. But in this case, in this time we don't need to bother with the division things, because it is directly given in a distribution table. And two Karhoffs, so the two Karhoffs is actually considered as a two server of this system, Abel and Baker. Abel is better able to do the job and work bit faster than Baker. So as you know that there are two Karhoffs, Abel and Baker, but Abel is bit young, so he can work bit faster than Baker. So that's why it is a condition. And the distribution of the service time is shown in table 2.12 and 2.13. So now we are going to have two separate distribution table for service time, because we are having two different server. So in total we are going to have three distribution table, one for interval time, another is service time of Abel, and another. As you can see from the picture that there are three distribution table. One is interval time, service time of Abel, service time of Baker. And from the service time of Abel and Baker, you can also justify that yes, Abel is a work bit faster, because he takes minimum of 2 minutes and maximum of 5 minutes to serve a customer, whereas Baker takes 3 minutes maximum and 6 minutes minimum to, 3 minutes minimum and 6 minutes maximum to serve each customer. So Baker is work bit slower than Abel. So simulation will start with some simplifying rules as well. There are one or two simplifying rules, and we need to consider the rules as well, because it has a good impact in the simulation. So let us read down the simplifying rules. The first rules is that Abel get the customer if both Karhoffs is idle. Suppose both are idle at a particular time, and then a new customer arrives. So that particular customer will be served by Abel, because Abel is work bit faster. That's why always it's happened that if both are idle, then a new customer arrive. Okay, fine, Abel serve him, something like that. Okay, it works like that. The next rules is if both are busy, the customer being served with the first server to become free. So suppose both are serving others customer, in that particular time new customer arrived. So that new customer will be served by whom it is decided by who will become free first. If Abel become free first, then Abel will serve the new customer. If Baker become free first, then Baker will serve the customer. And this is our objective, to estimate the system measurement of performance. A simulation of 1 hour of operation is made. So we have to do a simulation of 1 hour. That means we have to touch or cross 60 minutes. Our target is to touch or cross 60 minutes. Suppose we are in clock time 58 and because still we are not touching or crossing 60, and at that particular time a new customer arrive whose service time is say 5. So it still has to serve this customer, because still this server does not touch or cross 60 minutes, because 1 hour is the condition. So he will start serving the new customer. The service time of new customer is 5. His service will start at 58 minutes and end with 63. So now we can say that okay, fine, the server will have touched or crossed the 60 minutes. So that's how it works. So just remember, whenever there are a target set that we have to simulate the system for 1 hour or 24 hours, then we need to touch the time or cross the time. Okay, until that we need to serve, we need to still serve the customer. But in previous slide we have seen that there are a particular number of customer, like 10 customer or 20 customer. In that particular time we don't need to consider about how many times, but rather than how many customers. But here we have to consider how many times, that means 60 minutes. The problem is to find how well the current arrangement is working. So after doing the simulation for 60 minutes, we need to say that the current arrangement is okay or not. Okay, so let's move on to. So as you can see, the simulation is started, and there are number of customer being served, and also there are some skip point, because if I put all the table, it will become very big. So each and every row follow the same rules. So if we discuss about some of these rows, then it will be clear to us. So you can also see the distribution tables are also here, and random digits are actually given in the simulation table. So that's why I am not putting the random digits separately here. But as we said that to start a simulation table, in the problem set we can find the situation, all the distribution table, and against them we will find the random digits. So this will be the random digit set will be given in the simulation, the problem set. So we don't need to consider that from where it came. So it will be given in the distribution table, or sorry, problem set. So let us begin. We'll start with customer 1. So as we said that customer 1 does not have any interval time, so we don't need to use any random digit for first customer. So we just use hyphen in the place of random digit for interval, also hyphen in the place of random time between arrival. And we have said that always the service time, arrival time of first customer is 0, because when first customer arrive in the system simulation clock will start tick-tocking. So that's why the arrival time of first customer is 0. But if there is another condition in the scenario that the system will start at 8 AM, then the arrival time of first customer should be 8 AM, like 8:08:00, and the other part will follow the pattern. Okay, so for now just consider that it is 0, and then random digit set also we can find out in the problem set. So random digit for service time is given as 95. So 95 first customer, when first customer arrive, what about the servers? I mean Abel and Baker, both are free. So we have seen that simplifying rules, if both are free, then the customer being served with Abel. So this 95 will be applied in the table of Abel. Okay, so 95 in the table of Abel, this one is Abel table, so this should be fall down into this range 95. So against this range the service time is 5. So Abel will take 5 minutes to serve first customer. So the first customer service is started at 0 minutes, service time is 5, and service ends at 5 minutes. 0 plus 5 equal to 5. And in the meantime server 2, that means Baker is free, time in queue, first customer does not have to wait in queue, so that's why is 0. Okay, so we are done with first customer. Let's move on to second customer. So second customer have a interval time, so that's why we need to use the random digit for interval time, and as we said that it will be given in the problem set. So the first random digit for interval time will be applied for the second customer, but the first random digit for service time will be the for first customer. So 26 is the random digit for interval time. We need to apply this in the interval distribution table. So this one is interval distribution table. So 26 is in this range. So against this range the interval time is 2. So we write down here that interval time is 2. That means customer to arrive after the arrival of first customer, 2 minutes after the arrival of first customer. So first customer arrive at 0. So 0 plus 2, so arrival time of second customer is 2. So when he comes, he found first he found first server busy. Able is busy to serving the first customer, and he will become free at clock time 5. But as we are dealing with double server, so still we have another chance to check what is the condition of second server. So we can see that second server is free. So the service of second customer will begin with the Baker. So his service began at clock time 2, and the random digit for service time is 21. So now we will check this random digit in the table of Baker, because the second customer is going to be served by the Baker. Okay, so 21 will be fall into this range, so that the service time is 3. So we said that service time is 3. So the second customer service began at clock time 2, service time is 3. So 2 plus 3 equal to 5. So his service end at clock time 5. So customer 2 arrive at clock time 2, his service began at clock time 2. So he does not have to wait in the queue. So that's why it is 0. And then next one, customer 3, the random digit for interval time 98. So now if it is 98, then the interval time is 4. So that means customer 3 arrive 4 minutes after the arrival of customer 2. So customer 2 arrives at 2 minutes. So 2 minutes plus 4 minutes equal to 6 minutes. So arrival time of customer number 3 is 6. So at clock time 6, what happens? Both server are free now, because customer Able is serving customer 1 and he become free at clock time 5, and Baker is serving customer 2 and he also become free at clock time 5. So when customer 3 arrive at clock time 6, he found both server are free. So now the simplifying rules: if both are free, then the customer will be served by Able. So the service will be started with Able. So his service will start at clock time 3, and that is random digit for service time is 51. So we will apply this one in Abel's table. So if it is 51, then it is in this range. So 51 against we found that service time is 3. So service start at clock time 3, service began at clock time 6, and service time is 3. So 6 plus 3 equal to 9. His service will end at clock time 9, and customer 3 also don't need to wait in the queue. So that's why it is 0. Let's jump a little bit. We move on to customer 5. So customer 5, random digit for interval time 26. We apply 26 and found that it is 2. So that means customer 5 arrival 2 minutes after the arrival of customer 4. Customer 4 arrived at 10. That means 10 plus 2. The arrival time of customer 5 is 12. Okay. So let us check the status of two server. Customer Able is serving customer 4 and he will become free at clock time 15. And this time you can see that Baker is free. So the service will be started with Baker at clock time 12, and the random digit for service time is 89, and we will check it in distribution table of Baker. If it is 89, then the service time is 6. So service is started at 12, service time 6. 12 plus 6 equal to 18. Then let's check one of them who is busy. So the next one, the 6, customer number 6, the random digit for interval time is 42. If it is 42, then it is in this range, and the interval time is 2. That means customer 6 arrive after 2 minutes of the arrival of customer 5. Customer 5 arrival time is 12. So 12 plus 2 equal to 14. So when customer 6 arrive in the system, he found both server busy. You see, server Abel is serving customer 4 and he will become free at clock time 15. Baker is serving customer 5 and he will become free at clock time 18. So the nearest server who becomes free, or the first server who becomes free, is Abel, and the clock time is 15. So that means customer number 6 has to wait at least 1 minutes to start his service. So that's why against the customer number 6 you can found that the waiting time is 1, because he arrived at clock time 14 but the service time is started at clock time 15. Okay, so it is we have confirmed that the service will begin with Abel. So we'll check the random digit for service time in the table of Abel. So 38 is in the range, so service time is 3. So his service is started at clock time 15, service time is 3, so 15 plus 3, 18. So the waiting time is already mentioned. So that's how we actually this pattern is actually followed throughout the time being, but just remember that we need to touch 60 or cross 60. So you see that in clock time 59 another customer arrived. Because it is 59, we have not touched 60 or cross 60, so still we need to serve this customer, and his service time is 63. So service is started at 59 and service time 3, and service end at 62. So now we can say that yes, we have touched or crossed 60. So now the server 1 can stop, and server 2 also stopped at when he served the customer 25. Service is started at 56, service time 6, so the service end at 62. So now both servers touched or crossed 60 minutes. So now we can relax, we can say that okay, fine, the simulation has ended. Now you see the value are calculated, the total service time of 2 servers and the total waiting time in the queue. So you can see there are no column for utilization, to find out utilization or the busy time or the idle time of the server, because we can find out idle time of the server from this following calculation, because you see that the busy time of the first server is can be find out by using the total busy time of second server is say server 2 utilization. You can find out there total busy time 43 divided by total runtime is 62. So that's how we can find out the utilization of second server, that means Baker, and also we can find out the utilization of Abel first server. So to do that, the same rules, and the total busy time 56 divided by total runtime 62. So that's how we can calculate the utilization. So that's why the busy time of server column is not there, because we can still calculate the service time or the busy time or the idle time of the servers. Okay. So after this simulation, still we have to answer some of the particular question that we have seen from the first from the single server, like what are the average service time, what are the average waiting time, and what are the utilization of first server, what are the utilization of second server. So so analysis of this simulation. Over the 62 minutes period, Abel was busy for 90% of time, and Baker was busy for 69% of time. So just doing the calculation in the rules that we have seen the previously. 9 of the 26 arrivals, almost 35% had to wait. So we have seen that total 26 customer arrive. From them, 9 customer has to wait in the system. The average waiting time of all the customer was only about 0.42 minutes, which is very small. So the waiting time is very small. Those those 9 who did have to wait in the queue waited average of 1.22. So those customer who actually waits in the queue have to wait in for average of 1.22 minutes. The summary: in the system seem well balanced. Once one server cannot handle all the dinner, and 3 server would probably be too many. So as we seen that we have to say what the current about the current arrangement, if it is okay or not. So this is the way we actually said it is okay or not. So we have seen that utilization is very good and the waiting time is also very small. So that's why we are saying that it is in very good balance. And if we said that on we have observed that this system cannot be handled by a single server, and also if we add another server, then the idle time of the server will become very large. So whatever arrangement are following right now is actually perfect. So this is how we end this simulation. This is how we said it is okay or not, and this is how we the second part of the single channel queue, that means double server. So hope you guys understand whatever we have discussed throughout the tutorials. So inshallah we'll meet in next tutorial. Till then, everyone please stay safe, stay home. Allah Hafiz. Assalamu alaikum.